Hello, my name is Bob D. Hilster, and I am your particle model guru. Today we're going to talk about the levels of the universe. The question is, what is this about? Is it about multiple universes? About valence levels? Well, sorry, in my opinion, there's only one universe. There are not multiple universes. This is about atoms, but it's not necessarily about valence levels. This is, in fact, addresses the question to only a partial degree about infinity that goes all the way up or all the way down. You've often heard the expression, it's turtles all the way down that holds up the earth. But for now, four levels of the universe seems clear, and I'm going to define what I mean by levels. And one more may be needed, and that's according to the particle model. But talking about more beyond that gets quite difficult. Okay, so let's talk about the particle model and these levels, and I'm going to define them this way. Each level has a physical center or core around which other objects orbit. So we can come down here to level A, which is our solar system, where the sun is the core, and we're going to move up to level B, where we have a galaxy that has a core, that has objects orbiting. Then we go to level C, and I've looked about, and does not appear to be any central core for any of these things they call groups, clusters, or superclusters. They do seem to hang together in groups, and what causes gravity is probably what causes that, but there's no sense of orbiting. Maybe there is, or maybe there isn't. Level 1 starts the way down, starting with atoms. Atoms have a nucleus, that's the core. Subatomic atoms, if they exist, also need to be a core, and we'll talk about that. Is there a level 3? Particle model at least suggests it, but there is no evidence. So you start at level A, and there's the solar system. Yeah, we're all familiar with that, and it has the sun as its core, and then the planets and other objects orbiting around it. Level B is a galaxy, and it has a core, and with all the things that we can see orbiting around the galaxy, you imagine there are more stars in there, and so things, the solar systems can exist inside the galaxy. That's level B. Level C, they have local galactic groups. Apparently there's 2 galaxies here. I'm not going to go into detail there, but they look around the skies, and they see some of these things in smaller groups. Here's the Virgo supercluster. That's in this is actually the Virgo sign, although this seems to be upside down from the sign, but nonetheless there's the Virgo supercluster, and it has multiple galaxies in it. So anyway, and I'm not discussing level C because I have no information to talk about. So we'll start a little bit more detail about level A, the solar system. The objects in the solar system are the sun, planets, moon, comets, asteroids, whatever else, and it's gravity, G1 gravity, that keeps these objects in orbit around the sun. And all the objects are made from atoms from level 1 and below. The mass of the solar system is measured using G1 gravity in units of kilograms, being compared to the kilogram standard. The only way we have a value for the mass of our solar system or the individual objects in it, the sun and moons and comets, is because we have a standard to compare it to. We measure the motion of an object against the motion of the standard, and we can assign it more or less a value. So we can measure the solar system and give it units of a kilogram, because the G1 standard is based on a G1, the kilogram is based on the G1 standard. The speed of the solar system, the particle field that keeps the speed of these objects to less than the speed of light due to drag. All of these objects from level A up are subject to drag. I mentioned drag in the video that I had earlier called faster than light versus drag. And it turns out that when you have atoms with nucleons in it, these objects are not going to move faster than light, because the faster they go, the less push G1 gravity gives them, and the more push back that it gives them, and the force to accelerate them slows down. The speed of the stars, for example, at the edge of the galaxy can be as high as 280 kilometers per second. What I didn't give was the speed of the planet as it moves around the galaxy, but nonetheless, the speed of the planets and the star and around the galaxy is around 280 kilometers per second. Okay, so in the galaxy, the objects are the core. You have solar systems and stars in the galaxy. The mass of our galaxy is estimated to be at 5.8 times 10 to the 11th solar masses. That is, you take the mass of the sun, multiply it by 5 times 8 to the 10 to the 11th, and you get the mass. And I presume this is the visible mass and not dark matter. In fact, I think when you add dark matter, you get numbers like 10 to the 42nd kilograms. Anyway, the speeds are comparable. This is the speed of the galaxy itself, 631 kilometers per second. The higher you go, the slower it is, the greater the mass. One would guess that if you're going to go infinitely up, that by the time you get all the way up, things are so large and so they're not moving at all. That would be my guess, but what information? We don't have any information. I stop at level B. Level C, I'm not even describing. Starting at level 1, going down, the objects included here are atoms that are in our periodic table, made from nucleons and G1 particles. I've been saying that over and over again. Because there's a level 2 that we're talking about, and now starting to talk about the nucleon as being an N1 particle. And gravity 2, G2 gravity, keeps the G1 particles in orbit around the N1. So the G2 gravity is the nuclear binding force, molecular binding force, that keeps things together, keeps the G1 in orbit around the nucleus. The mass of the atom is in kilograms. You can measure the atom in kilograms. And let me counter that with the fact that the mass of N1 and G1 cannot be measured in kilograms. The interaction is different. When you use the standard kilogram object as a comparison, it's made of platinum and iridium. These are atoms that have open space, and the G1 gravity passes through that object and on occasion interacts with it. But in the case of the N1 and the G1 gravity cannot pass through a G1 particle. A G1 cannot pass through a G1, and in fact, It can't pass through an N1. It can't go pass through an N1 because light, which is made up of a stream of G1 particles, when it hits a mirror, reflects off of the mirror, primarily reflecting off of the N1 particle. If it went on through, there'd be no reflection. So the mass of the atom can be measured in kilograms. I'm not sure they actually do it, but you could at least say, okay, here's the helium atom and here's its mass in kilograms. You can't use kilograms for N1 and G1. You have to have a new standard. A lot of work, a lot of thinking about how to even do that. The speed of the atoms are limited by the drag, not the frag, of the G1 particle field. As I've stated before, N1 particles have been accelerated, for example, close to the speed of light. In linear accelerators, they get them to move quite fast. So they can move fast, but in general, the N1 in nature doesn't move that fast. I mentioned 280 kilometers per second. The G1 particles have an orbital speed that is at or about the speed of light. And that's how we get the speed. They're built that way originally. Why they're built that way and why it's this way, that's a philosophical question that is left for another discussion. Now let's talk a little bit about the structure of the N1 nucleon and the G1 particle. The requirements for the N1 is that for G2 gravity to hold the G1 in orbit around the N1, there must be open space in the N1 and G1 for the G2 to pass through. And secondly, the G2 particle must be faster and smaller than the G1. It has to be faster in order to cause light to bend, light to change speed or direction. It can't be doing that if it's moving at speed c or slower. It has to be smaller than the N1 and the G1 in order to pass through it. That's a requirement of a particle model gravity. And at this level, the N1 and G1 must have open space. So let's look at three different options. Quantum mechanics, I'm talking about the structure of these atoms. The three options. Quantum mechanics has their idea. For example, the proton is made up of two up quarks and one down quark. And the neutron is made up of one up quark and one up quark and two down quarks. It's just kind of the opposite. And in quantum mechanics, the electron has no structure. It has no parts. It's a solid piece. A particle. This one is basically rejected based on the fact that the proton and the electron have positive and negative charge, and I have no information from anywhere that describes the physical property that gives the proton a positive charge and gives the electron a negative charge. Just because you write plus and minus on it doesn't make it a charge and doesn't cause it to move together. You need to have a physical property that causes them to move together, and I don't see that. So I'm not accepting that as the structure of the N1G1. Or you could have a number two, a rigid particle with open space. Somehow it's just built that way. That's an option. But it doesn't, in the particle model, it doesn't help solve another problem. So the third one I'm suggesting is that there are subatomic atoms. And as in atoms, at any level, or something, if you want to call it whatever, or a system that has objects orbiting, creates space. There's space in a galaxy. There's space in the solar system. There's space in a regular level 1 atom. Subatomic atoms provide open space since they have orbitals if the N1 and G1 particle are made from subatomic atoms. Then it satisfies this requirement that they must have open space. And it does. And the second thing is, so it provides the open space, and if the G2 particle is the orbital of the level 2 atom, it will be small, and it will be fast, and generally faster than the speed of light. So these particles would exist inside the structure of the N1 and G1 if the N1 and G1 were made from subatomic atoms. Level 2, talking about subatomic atoms, maybe there's a whole family of atoms. Maybe there's not just one atom. Just like we have a periodic table, you could have A1, you could call the atoms in the level 1 the A1 atoms, and in level 2, A2 atoms. That's really stretching it. But it has to have a nucleus, so I call it the N2 particle. That's the nucleus of the subatomic atom, and it has an orbital, the G2 particle. None of these objects exist in standard physics. They're just not there described in this way. They have their particles, but they're not described this way. There is no evidence for the level 2 atom nor the level 2 nucleon. That's no evidence for this or this. However, the G2, I determined using refraction that there might be a G2 particle causing refraction because it looked like there was a force of gravity around the prism causing light to bend. And since I'm generally have an opinion that things are made of particles and that gravity, Newtonian gravity was a particle, I immediately assumed that there was a gravity particle for light, bending of light, and talked about the G2 particle and then hence the G1. There is an interesting point to be made, and I'll be showing this in another video whenever I get to it, but in some cases, as in diodes and transistors, the G2 force field inside these components behave very much like an electric field. That may not be the only case. So the force field that you see described, you read it in the literature, and it says there's a electric force field inside the transistor causing the electrons to move in a certain way or not move, depending on the voltage, for example, on the base of a transistor or the voltage across the diode. They look very similar. Maybe there is a correlation between the G2 and existing evidence of an electric field. But we don't have an electric field in the G2, in the particle model. We have G2 gravity. In summary, the G2 particle is needed to cause the G1 particle to change direction and speed as in refraction. The G2 needs to be faster than the G1 in order to catch up to it and even interact with it. The G2 needs to be smaller than the N1 and the G1 in order to pass through and interact such that there can be a gravity-type interaction. And hence the N1 and the G1 need to have open space. It's the subatomic atom that provides all of these characteristics if the N1 and the G1 particles are made from subatomic atoms that satisfy the criteria. That's, in summary, that's where the G1 particle comes from. So we have these levels. And this is an arbitrary distinction of that of making levels based on these having a core around which objects exist, an orbital system. You could go all the way up, and you got A and B seems okay. C may have orbitals. It's not clear to me. The further up you go, if you believe infinity up, the greater these objects, the larger the mass, whether and they're in kilograms. And to my mind, the slower they go, and if you ever really got to infinity, it would seem like they're stopped. They're not moving. The move on the way on the going lower, starting with the atom and going down, there seems to be obviously good evidence for the level 1. You could argue that subatomic atoms, that's pretty speculative, but I maintain that if there were subatomic atoms, it needs a nucleus, it needs the N2 particle, and that's where the G2 particle comes from that is moving faster than light. G3, maybe there's a G3 particle that keeps the subatomic atoms level going, and you could make a better argument going all the way down at infinity. But in this case, the particle gets smaller and smaller and smaller and smaller, and it has to go faster and faster and faster and faster, and I don't know what you get at the bottom. Being an engineer, I'm happy with levels A and B. And I'm happy with level 1 and reasonably happy with level 2. Not going to even go into level 3. My name is Bobby Hilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention. Where are you? Oh, crap.